Hello everyone, my name is Siddharth and today I want to talk about my research topic on how to reduce carbon emission from the building. Earth, the only planet in solar system which has mixture of different gases like oxygen, nitrogen, carbon dioxide to form a breathable and livable environment for all the living creatures. From last couple of decades, Earth is facing a major problem in climate change, which is mainly caused by us humans. When we talk about climate change and increasing in air pollution, we always think of large amount of vehicles stuck in traffic or maybe pollution caused by the industries. But not many people know that buildings actually have a higher environmental footprint than transportation or the industries. Although it is less evident, buildings produce more carbon dioxide compared to the transportation sector. It is important to reduce the carbon emission through buildings because the greenhouse gases such as carbon dioxide traps the heat within the atmosphere, which helps in warming up the globe, and it can lead to a major climate change problem. The various solutions or methods which can be implemented through which the carbon emission from buildings can be reduced or stopped. To reduce the carbon emission from building, we first need to know the many ways through which the building emits carbon. Starting from the selection of building material to different functions carried out inside the building. To reduce the carbon emission, it's always good to start early by selecting proper material at the initial stage. We need to be careful while selecting the building material which emits less carbon into the atmosphere. Ventilation. As an architect, it is our duty to provide natural ventilation by not including any external sources for achieving thermal comfort inside the building. The buildings depending on HVACs or any external sources of artificial ventilation emit more amount of carbon into the atmosphere. Recycled building material. Selection of recycled building material which has less negative impact on the environment. Always support the green suppliers and vendors that embrace green practices. Sustainable architecture. Sustainable architecture methods like green roofs, vertical gardens are most effective in reducing carbon emission and increasing the surrounding air quality. Implementing sustainable architecture methods for construction which reduces the emission of carbon and increases the life of the particular building. Water usage. Reusing water or grey water filtration is also a cost-effective way of reducing carbon footprint and increasing the water conservation. Techniques like rainwater harvesting result up to 50% of saving in the regular water usage. Renewable energy. The building's carbon footprint can be reduced by sourcing its operational energy from the environmental responsible sources or by generating renewable energy on site. Using the walls or roofs of the building for solar air heating, solar electric photovoltaics systems, or solar water heating can permanently eliminate part of the demand of conventional energy. Architecturally looking, and British architect Michael Pollan once stated that architects must urgently go beyond creating sustainable architecture that minimizes damage to the planet and design buildings that help repair it. Michael believed in designing buildings which help in repairing the planet by minimizing the damage caused by the construction. This theory of architecture helps in reducing the natural carbon footprint of the building by constructing the building beyond sustainable architecture. I did a couple of case studies based on the architectural theory and the research question of reducing the carbon emission from the building. The Eden Project. One of the famous projects by Michael Pollan, which is based on his architectural theory and is located in the UK. This project was inspired by the dragonfly wings to build a horticulture on hillside without disturbing the topography of the site. The giant structure is made up of a special material which is known as ETFE or insulating polymer, whose frames are shaped as polygons or hexagons, which is bolted together. The project is a great example of how humans can interact with the space and environment. Moving to case study 2, the Rubens, which has the largest living wall and is located in London. The wall attracts wildlife into the dense urban environment of London, and it also boosts the green appeal of the area. Green wall not only promotes mitigation of flood but also absorbs rain, improves air quality, absorbs noise, and it also helps in keeping the building cooler in summer and warmer in winter. Case study 3, the Mazda City, which is located in Abu Dhabi. The city of Mazda is one of the world's most sustainable urban communities which aims for net zero carbon emission by making the whole city self-sustaining and not depending on any other external sources of energy. The construction of each building in Mazda City is done with low carbon cement and uses 90% of the recycled aluminum. When compared to the American Society of Heating, 40% water and energy consumption is reduced. Based on the architectural theory, research question, and case studies, I now want to try and implement these strategies in one of the cities of Philippines called Naga City. Naga City is basically a second-class independent component city in the Bicol regions of Philippines. The population of Naga City ranges approximately about 196,000 people with very dense polluted buildings where most of the constructed buildings are not taken into consideration for carbon emission. Naga City comes under one of the most underdeveloped polluted cities, which is most prominent to be affected by the natural hazards like floods, typhoons, and heavy rainfalls. Taking all the elements into consideration, I now want to propose a prototype design for the site in Naga City, which is suitable for all the harsh weathers and making it self-sustaining by having less carbon emission through the buildings. The prototype which I've designed is going to be placed in the selected site D, which is located in Pacol. The main reason for selecting this particular site is because the site is far from the city, which is almost 8 to 10 kilometers. So it is much suitable for me to show how the site can be self-sustaining and not be dependent on any nearby external sources. Some of the methods which I will be implementing for the particular site is going to be adding green walls, which helps in maintaining the thermal comfort of the building and which purifies the air of the surrounding, rainwater harvestment for collection of excess water and reusing it. Looking at the weather conditions of Naga City, the row houses have been given a higher plinth level so that the building is less affected during floods, and it also helps in collecting the runoff waters. Coming to the material selection of the prototype, the best material which can be used for construction should be a plant-based material like biomesh and brick, straw insulation, wooden window frames, engineered wood, and it goes on. By using these kind of material, we can achieve net zero or net positive carbon emission from the building. The prototype proposal is a series of row houses which are self-sustaining with proper ventilation, wastewater management, and good value for green architecture. The main concept of the prototype is to reduce the total carbon emission from the building. The whole site will be self-sustaining without emitting any carbon into the atmosphere, impacting a huge difference in the climate change. The main type of emission which needs to be calculated throughout the building is embodied carbon, which is emission footprint coming from the building material during the process of manufacturing till the fixing stage, which emits particular amount of greenhouse gases. I've also mentioned the references for the presentation at the end. Thank you.